Good morning, my dear students. In today's class, I am going to discuss about different MTI parameters that will indicate the performance of MTI radar. The MTI parameters are MTI improvement factor, subclutter visibility, clutter visibility factor, and clutter attenuation and cancellation ratio. The first one is a MTI improvement factor. It is the signal to clutter ratio at the output of MTI system divided by signal to clutter ratio at the input averaged over all target radial velocities. And the second parameter is subclutter visibility. It is the ratio by which target echo power is weaker than coincident clutter echo power, still detected with a specified probability of detection and false alarm probabilities. And next parameter is subclutter visibility. It is the signal to clutter ratio after cancellation or Doppler filtering that provides stated probability of detection and false alarm. And next, fourth parameter is clutter attenuation. The ratio of clutter power at the canceller input to the clutter residue at the output normalized to the attenuation of the single pulse passing through the unprocessed channel of the canceller. It is nothing but a clutter attenuation. And fifth parameter is a cancellation ratio. The ratio of canceller voltage amplification for a fixed target echoes received with a fixed antenna to the gain for the single pulse passing through unprocessed channel of the cancel. It is cancellation ratio. These 5 parameters will indicate the performance of the radar. And next concept is there are limitations to the MTI radar because equipment instabilities and variations in the clutter and finite time on the target all will limit the performance of the MTI radar. The MTI radar performance will be reduced due to equipment instabilities and internal fluctuation of clutter and antenna scanning modulation and finite time on limiting in the MTI radar. First parameter is equipment instabilities. The sufficient care should be taken for designing and construction and maintenance of the performance of the MTI radar. Otherwise, the performance will be limited. And pulse to pulse changes in the amplitude, frequency or phase of the transmitted signal will limit the performance. And the changes in the shallow or coho oscillator or jitters in the timing of pulse transmission, variations in the time delay through the delay lines, and changes in the pulse width will limit the MTI performance. These are the equipment instabilities. And next one is internal fluctuation of the clutter. Clutter means stationary target. There are certain stationary targets are there like buildings and towers and mountains, hills. It will produce echoes with equal amplitude, constant amplitude and phase. But certain clutters are there. There are variable clutters are there. Like trees, vegetation, sea, rain, and all this varies with the time, and it will limit the MTI performance of the MTI radar. The experimentally measured power spectra of the clutter signals is W of F equal to magnitude of g of f square, that is equal to magnitude of g naught square e power minus a f by f naught whole square, where w of f is clutter power spectrum as a function of frequency. G of f is a Fourier transform of input waveform. F naught is radar carrier frequency. A is a parameter depending upon the clutter, whether it is a vegetation or a sea or rain, it will depend upon the clutter. Next parameter is will affect the performance of MTI radar is antenna scanning modulation, and as the antenna scans the target, it observes the target for a finite time. That time is T naught, that is equal to NB by FB, that is equal to theta B by theta S dash, where NB is number of hits received and FP is pulse repetition frequency, and theta S dash is antenna scanning rate, and theta B is antenna beam width. And if the clutter spectrum is too wide because the finite time on the target is a short, or observation time is short, so that the spectrum will be broader. And next concept is MTI, the difference between MTI and Pulse Doppler Radar. The MTI radar refers to a radar in which pulse repetition frequency is low enough to avoid ambiguities in the range, but it has blind speeds. In MTI radar, the ambiguities in the range are less, but blind speed issues are there. But in Pulse Doppler radar, it has high pulse repetition frequency that avoids blind speeds but experiences ambiguities in the range. And then this MTI radar uses delay line cancellers, but Pulse Doppler radar uses range gated Doppler filters. In MTI radar, the power oscillator like a magnetron is used. In Pulse Doppler radar, the klystron is used. And in MTI radar, the detection performance is limited by the transmitter leakage or by the signals reflected from the nearby clutter. But in Pulse Doppler radar, the detection performance is not affected by any type of disturbance because of the receiver is turned off. Because while first we are going to transmit a pulse, and next we are going to wait for the echo. Therefore, it will not affected by the external disturbances. Okay, this is about today's class, and thank you very much.